Hey everybody, this is week 9 of our class. We're more than halfway through. You guys did awesome on the midterm. We had a couple of technical difficulties this morning, so I'm re-recording this so you guys can listen. So there's not going to be anybody on this class, so when I ask questions, I just want you to think about it. Nobody's going to be answering them. I'll answer most of them for you, but a lot of them were answered this morning. We're going to talk about what happens to your body during exercise. So how do you feel when you exercise consistently? Just take a second and think. When you are working out every day, how are you feeling? Do you feel tired? Do you feel energetic? Do you sleep better? How do you feel when you take a week off of exercising? So that could go either way. You could feel well rested. You could feel like you have a lot of anxiety. Some people get really hyper when they haven't been working out. And some people just need a break. So how do you feel when you take a week off of exercising? How do you feel right after you exercise? Some people feel really hyped up. Some people feel tired. And how do you feel when you over-exercise? Now, what's happening when you exercise? We're going to talk about a couple of things that happen during exercise, and some a little bit after. First thing's easy. Your temperature goes up. You burn more calories. Your heart beats faster. Your blood moves away from your stomach and your intestines because you really don't need them. You have a whole bunch of hormonal changes that we're going to talk about. You get more blood to your brain, and you get little tears in your muscles to help them build and regrow. So we're going to talk about each of these a little more in depth. Now, for temperature rising, why does your temperature rise when you exercise? Because you're moving. Your muscles are moving. Anything that you do that is movement and calorie burning, you're creating heat. So that extra muscle movement is going to cause your temperature rise. Now, your body's going to try to keep everything the same. So thermoregulation is trying to maintain your body heat. To do that, we sweat. So what does sweat do? I already gave you kind of the answer, but I want a little more in depth. So sweat regulates your temperature by cooling off your skin. Now, one thing we really want to pay attention to is when it gets too hot. So most of the time when you start getting over 104 degrees, some people can get higher, but when you start getting to about 104 degrees, that's when you need to start really paying attention for heat stroke. And there are a lot of symptoms of heat stroke that really aren't too big of a deal. You might see headache and dizziness or lightheadedness. Maybe you're hot and red. You have even nausea or vomiting. There are things you need to watch for with exercising, but the big one you want to pay attention to for heat stroke is lack of sweating. If you see somebody that is extremely hot and they stop sweating and their skin ends up dry, you need to pay attention to them because they're going through heat stroke. So they need to hydrate, get their electrolytes, get out of the heat, stop exercising. Because that's very, very important. That'll be the one thing you really want to pay attention to when somebody is exercising and when you're watching for heat stroke. And why is that? Why is that the telltale sign? Because your body is not doing the one thing it's supposed to. It's stopping its thermoregulation and it can't control your heat anymore. So it's keeping all that extra heat in, it's not letting it out, and it's not trying to cool off your skin. Now, calorie burn. Why do you burn more calories while you're exercising? Part of it is just because you're hotter. You're using more muscles, you're breathing out more. And what are the things that affect the number of calories that you burn? We talked about that a couple weeks ago when we actually talked about calories and exercise. So one of them is going to be your age. So generally, you are going to burn more calories during exercise than I am. Seth is going to burn more calories than Maria or Nadia because he's a boy. And men tend to burn more calories than women do just because they tend to have more muscle mass. What you ate that day or the day before can affect the number of calories you burn. What you're drinking, how hot you are, the weather, what you're wearing. There are all kinds of things that go into the number of calories that you burn. Where do those calories go? So if you are burning fat, where are they going? Or We know from physics that mass just doesn't go away. Energy just doesn't go away. So where does it go? Most of it you breathe out. You actually breathe out a majority of the fat or the calories that you burn. So that'll be a nice fun fact when somebody talks about how much weight they lost. You can always tell them they actually just breathed out however many pounds that they lost. Now, do certain types of energy or certain types of exercise burn more calories than others? Yeah. Aerobic exercise is typically going to burn more calories than anaerobic exercise. Why is that? Because aerobic exercise, you're using oxygen, so you're breathing in and out more. So ordinarily, you're going to burn more calories because you're breathing more, you're using your muscles a little bit more, but you are using you are going to burn more calories after an anaerobic workout. Partly because you're gaining muscle, partly because your muscles are still working more afterwards. So you're going to burn more calories during aerobic exercise, but more after anaerobic exercise. And that answers the next question. Do you keep burning calories after exercise? Yes, you burn some after aerobic exercise, but more after anaerobic. Now, what is an example of aerobic exercise? Running long distances, swimming, anything that's going to have you breathing heavily for the most part is a longer term workout. Anaerobic is going to be a lot shorter. A sprint can be anaerobic exercise, weightlifting, things that are more short in duration. Now, when you exercise, your heart rate also increases. Why? Because your muscles are being more demanding. They need more nutrients and oxygen, so the blood has to get into your muscles faster. And the maximum your heart rate should be while you're exercising. This is not going to apply to you guys. Normally, it's going to be 220 minus your age. That is only applicable for people over 20. So you can use that to figure out your parents' maximum heart rate, not necessarily yours. As a general rule, you typically want to stay under 200, but the 220 minus your age will be a good rule of thumb for anybody under 20 or over 20. So if we were looking at mine, if I'm exercising, the maximum my heart rate should be is 195. So if I'm going over 195, I'm probably doing too much and I got to watch it. Now, will your blood pressure also increase while you're exercising? So your blood pressure is just how much pressure is being put on your arteries as your blood's pumping against it. So you are going to have more pressure because there's more blood being forced through them at once. Is that a bad thing? No, not necessarily. It can be for somebody who already has high blood pressure and they need to watch how high it's going. Your blood pressure is not going to change a whole lot while you're exercising. It's got kind of a range it's going to stay in. If somebody is already needing to watch their blood pressure, they need to pay attention to their blood pressure while exercising too. So overexertion can be an issue for them. Now we're going to do a little exercise. We did Marie and Nadia did this morning. So I'm going to have you find your pulse. You can find it. I think it's easiest to find it against your neck. So if you're looking for your carotid artery, if you want to look up a picture of your carotid artery, and I can actually post it onto the Facebook page too. But find your pulse and grab a stopwatch or your regular watch or your phone, anything that'll give you seconds, and count how many times you feel your heartbeat in 10 seconds. And once you have that, multiply that by 6. Now to get a little bit more accurate, you can count it for 30 seconds and multiply it by 2. The longer you calculate or longer you count it, the more accurate it's going to be for beats per minute. So it can change pretty regularly, but that'll be how many beats your heart how many times your heart's beating per minute. Now, What I want you to do is do 20 jumping jacks and then find your pulse again. So after you finish that, you'll tell me which one is higher, before you exercise or after. In theory, you should be able to go ahead and tell me which one is going to be higher. Does your heart beat faster during or before or after exercise? It even says at the top of this page, your heart rate is higher during and after exercise. So check your heart rate, see if it changes a whole lot right after you exercise, and check it sometimes during when you're exercising on a regular basis. That way you'll be able to keep track of your heart rate. And it'll be really interesting to see before you even get out of bed in the morning, check your heart rate, because that'll be your true resting heart rate before you even get up, preferably without even being woken up by an alarm. Yeah, this one's a pretty short one, but your blood moves away from your digestive muscles. Why? Because you don't need them. Your blood needs to go to your brain so you can react, and your muscles so that you can do something. So if we're looking at it from an evolutionary standpoint, you're probably going to be exercising to run away from something or run towards something. So you're not going to be getting rid of your digestive system very long term, but there are a lot more important things happening than you trying to eat some food. Now, how can that be an issue? So just to give you an example, when that happens, if there is anything in your digestive system, so if there's anything in your stomach or your intestines, it's all of those organs are just going to relax. So everything that's been holding them tight and all the blood that's been pumping into those muscles that are around them is just going to relax out. So anything that was in there is going to go through you very quickly. That means you may have noticed if you try to go for a run right after a meal, you can have diarrhea. That can be a huge issue for some people. If you give yourself about 3 hours after eating a decently big meal to exercise, normally you'll have everything out of your system. Now, on the positive side, if somebody's constipated or if there is a lot blocking up their digestive system, exercising can be a great way to keep everything moving. And they will often recommend regular exercises to keep your digestive system regular. Hormones. Hormones are going to be the longest one that we focus on today. So we're going to talk about which hormones go up during exercise and which ones go down. Now, insulin, where do you normally hear about insulin? Normally with diabetics. For type 1 diabetics, they typically have to inject insulin because they're either not making enough or it's not working the way it's supposed to. So they inject it if their blood sugar gets too high to help bring it down. So what does insulin do? It gets rid of the sugar in your blood. It stores it as carbohydrates and fat in your fat cells or in your muscles or in your liver. Wherever it needs to go, it stores it now. Would your insulin go up or down during exercise? It's going to go down because you don't need to be storing energy during exercise. You need to be bringing it out and using it. Now, glucagon does the opposite. Glucagon releases your fat from your fat cells in the glycogen from your liver to increase your blood sugar. Is that going to go up or down during exercise? That one's going to go up because it's releasing the energy so that you can use it. Cortisol is your stress hormone. It's going to release fat and protein from pretty much anywhere it can get it to be used for fuel. So is that going to go up or down during exercise? That is also going to go up. Now, for that, just as a reminder, exercise is a stress on your body. It's generally a good stress as long as you're not over-exercising, but it's still a stress. So cortisol is going to go up. Epinephrine is going to increase blood flow, increase your blood sugar, and help you use glycogen and fat for energy. So is that going to go up or down? That one's going to go up too. Anything that's going to increase your blood sugar is probably going to go up during exercise because it's got to put energy into your blood so it's easily used. And norepinephrine does a lot of similar things to epinephrine, but it also constricts blood flow to body parts that you don't need during exercise. So what is an example of the body part you would not need during exercise? Your digestive system. So would that go up or down during exercise? Up. Testosterone, for this one, for the sake of this presentation, is involved in muscle repair in both men and women. Very important to remember. Both genders use testosterone. It's very important, and you use it to help fix your muscles from the little tiny tears you put in them while you exercise. That's also going to go up during exercise. Human growth hormone, or HGH, it helps you grow. Makes it easy because it's right in the name. It also helps support your immune system and helps you metabolize fat. Is that going to go up or down during exercise? It's actually going to go up right after exercise. Now, insulin-like growth factor. It is similar in composition to insulin. It doesn't really do what insulin does. It helps HGH fix proteins and fix muscles. So that is also going to go up after exercise. Now, brain-derived neurotrophic factor helps your brain cells. That is very, very, very important. It helps stimulate brain cell production. Very important. And that goes up during exercise, and that we'll talk about a little bit more later. Why would we want to stimulate brain cell production? To help you think and react better. Now, what could that potentially mean for older adults? And we're also going to talk about that later. So I want you to take a second to think about that. What could increased brain cell production mean for older adults? So why do you think better during exercise? Now, do you think better during exercise? Do you react better? Some people go for a run to clear the head. Some people notice that if they're, excuse me, my goodness. If they exercise during work, they're able to get back to work and they're working better. It's one of the reasons that some workplaces have gyms. It's not necessarily for the employees exactly. It actually makes them more productive employees, so it's better for the company. It's just because you're getting more nutrients and oxygen to your brain. There's also an increase in activity in the hippocampus, and I know Marie's going to know what the hippocampus does because it's involved in learning and memory. Now, with the increased activity in the hippocampus, with the increased nutrients and oxygen in the brain, and the increase in the brain-derived neurotrophic factor, what does that mean for older adults? Thinking about degenerative brain diseases, looking at the typical older adult issues, lack of memory, lack of cognitive function. The hippocampus actually decreases in size as we age. So what could this mean for them? They'll remember more as they age. I mean, this could come with when we're looking at degenerative diseases or diseases that older adults would typically get when it comes to their brain's memory learning. They'll be able to keep track of everything for longer periods of time. And that is huge for us since we're living longer as humans, relatively. We want to keep track of our brains for longer, obviously. We want to be able to remember things. We want to be able to learn longer. So for that, for older adults, making sure they continue exercising is very, very, very important. Aerobic exercise actually increases cognitive function, and resistance training increases memory. So both are needed. Yeah. Now, this might get me in trouble. So, if any of your parents come back to you for this, I never said anything. But maybe next time they lose their keys, you can say, "Oh, Mom, maybe you should go work out with me next time," or, "Oh, Dad, maybe you should go exercise with me next time because it could increase your cognitive function and increase your memory." Now, if they get mad about that, I never said it. But always a good idea. Get them involved with your exercise. Now, the important part-ish of exercise are going to be the micro tears that you get in your muscle. Now, micro tears in your muscle is actually a really good thing because it helps your muscle adapt, rebuild, and grow. Muscle growth is called hypertrophy. Now, if you don't feed your muscles properly, what's going to happen? You're going to tear your muscles, and then what? If you don't get enough protein, if you don't get enough nutrients, what's going to happen? Nothing. You keep those tears in your muscles, they don't rebuild, they don't adapt, they don't grow. It's a bad thing. You have to feed your muscles properly to be able to rebuild them and for them to get better. Now, there's a big difference in a couple of the potential side effects of exercising when it comes to your muscles. Delayed onset muscle soreness, or DOMS, is just discomfort. It's basic soreness 1 to 2 days after a workout. And it's just your muscles recovering and adapting. It's not pain, it's discomfort. And all it is those little micro tears coming back to bite you. It's your body rebuilding it, and your body adapts and becomes bigger and better after it repairs those little tears. So that's when you're feeling that, that's DOMS. Now, soreness is not lactic acid buildup. I feel like I have to say this a million times everywhere. Soreness is not lactic acid buildup. That's actually a little burning sensation during exercise is a lactic acid. If you have lactic acid that is sitting in your muscles for longer than the exercise, that is a bad thing. So if we go into, you may have learned this in biology, when we go into how your body works and how it produces energy, your body produces lactic acid because it's not being during anaerobic exercise. Anaerobic exercise is not using oxygen. Now, as soon as oxygen gets introduced back into the system, lactic acid continues the cycle. It gets converted to pyruvate. So it should not be there for a long time unless you are completely out of oxygen for a long period of time, which would be a really bad thing. All lactic acid is supposed to do is reduce your body's capability to do more work during anaerobic exercise. So it's your point that you know you need to stop because it's that burning sensation when you really can't push your body anymore. And it's basically not going to stop that muscle and say, nope, you can't do any more till I get some oxygen. You're just going to have to supply me with what I need or I'm not going to keep going. That is all lactic acid is. It is not soreness. It is that muscle burn you feel during exercise. If you have lactic acid buildup afterwards, that's not a good thing. All it's to do is to restrict you from doing more work when it knows you can't go any further. So it's to stop you at the point of completing your anaerobic exercise and having to go into your aerobic exercise. So needing that oxygen. Now, rhabdomyolysis, or some you may have heard it called rhabdo, is a very bad thing. It's extreme damage to the muscle to the point that the fibers cannot repair themselves. That you'll see, that is actually going to be pain in the muscle. Pain, swelling is a big tell for rhabdo. Dark urine and organ failure. Now, why does that happen? Now, people will experience dark urine is the big tell. Dark urine means your kidneys are having a lot of issues. Now, when you have rhabdo, it means that there's a big damage to the muscle fiber. When that happens, the contents of the muscle fiber are coming out, and the muscle fiber basically dies. And everything has come out. It has to be flushed through the body, which puts a lot of stress on the organ that is supposed to be flushing things, your kidneys. When that happens, they get clogged, and they just get completely overloaded. That's why you get dark urine, because they can't filter properly. They're not doing what they're supposed to. They're trying to get everything out. And that's what you're seeing. You're actually seeing the contents of your muscle fibers in your urine, where your kidneys trying to get it out. They get clogged, and when your kidneys get clogged, they're not doing the basic thing that they're supposed to be doing, and they'll fail. That is the worst case scenario of rhabdomyolysis. So the tell will be, not everybody is going to go into organ failure when they have rhabdo. It happens. It happens when you way overwork your muscles, you're sore for a very long time. Rhabdo is going to be sore and swelling for several days. And your body just cannot repair itself. It is not the same thing as DOMS. DOMS is just your body. You overworked your body, but it is adapting correctly. Rhabdo, your body is not adapting. It is just giving up at that point. So the big difference between the two will be, or the big tell between the two, even just mild rhabdo, is going to be the swelling. You're not going to have nearly as much swelling with DOMS as you will with rhabdo. All right, let's go over a couple of things. What is the telling sign of heat stroke? That the person stops sweating. Very, very important. Why? Because it means their body's not doing what they're supposed to. They're not, the thermoregulation is not continuing as it should. Sweating is there to help regulate your temperature. So if they stop sweating, your body is just saying, nope, I'm done. Now, would you burn more calories exercising your upper or your lower body? This is going to be kind of a drawing conclusions type of thing. Are you going to burn more calories exercising upper or lower body? I'm going to give you the answer. It's lower body. Why? No, they're bigger muscles. That's it. They're bigger muscles. They require more energy to get the nutrients where they need to go. They require more energy to do what they're supposed to. That's it. Just because they're bigger muscles. You have bigger muscles in your legs than you do in your arms. Now, what hormone of the ones that we talked about decreases during exercise? There's only one that we talked about that actually decreases during exercise. It's the one storage hormone we talked about. Insulin. It was even the first one we talked about. What is the hippocampus? That's that part of your brain that controls memory and learning. Important with exercise because exercise helps your hippocampus. Does lactic acid buildup cause muscle soreness? If any of y'all get this wrong on the test, I will come after you. Lactic acid buildup does not cause muscle soreness. What does it cause? That burn while you are exercising. And if any of y'all get this wrong in the test, because as a reminder, the check yourself part of the presentations normally were the test questions. Just a reminder. So you can almost guarantee that that will be a test question, because I want you to remember that. And I want you to correct anybody who tells you that lactic acid buildup causes muscle soreness, because it doesn't. It causes the muscle burn. And then you can even draw them a diagram of the cycles for energy production if you so feel. But lactic acid is just that limiting factor of your body telling you, nope, I don't think I'm going to do this anymore. And that it needs oxygen. Lactic acid buildup does not cause muscle soreness. Now, your homework this week is to explain the difference between lactic acid buildup, DOMS, and rhabdomyolysis to one or more person or persons. So, explain the difference between lactic acid buildup, DOMS, and rhabdo to one or more people. So that is your homework. Thank you guys, and thank you for your patience in waiting for this. And I will see you guys next week.